Welcome to video 4, 3.1 Extrema on an interval. So now we are beginning our brand new material. All right, so we're going to focus on extrema, which are max and mins. We're also going to talk about critical numbers and how to find those, and how do we use those to find our extrema. So let's go ahead and begin. Well, what is extrema? So the definition of extrema. Let f be defined on an interval I containing c, where c is some constant. Okay. F of c is the minimum of f on that interval if f of c is less than or equal to f of x for all x values on that interval. And then similarly, f of c is the maximum of f on that interval if f of c is greater than or equal to f of x for all of the x values on that interval. So the minimum and maximum of a function on an interval are the extreme values, or the extrema. Okay, so the minimum and maximum of a function on the interval are also called absolute minimum or absolute maximum. Sometimes you might refer to those as global min or global max, but more so you'll see absolute max and min there. Okay, so let's quickly look at this diagram to look at these graphs and see maximums and minimums. Okay, so if we're looking at this graph, yes, we have f being continuous on our closed interval. All right, so this does in fact represent our minimum. We could even say that that's the absolute minimum. And this represents our absolute maximum. It's a closed circle. Versus over here, the only difference is this endpoint here is an open circle. So therefore, we can no longer say that this is a maximum. So it is not a maximum at that point. Similarly, for this next diagram, this bottom portion is an open circle. So it's not a continuous function, all right? But since that's an open circle, that point is no longer a minimum. This leads to our theorem, 3.1, the extreme value theorem. So the extreme value theorem says if f is continuous on the closed interval, then f has both a minimum and a maximum on that interval. So it's continuous and it's a closed interval. Okay, so those are the keys. Then we know we have a minimum and a maximum. What I want you to do right now is I want you to pause the video and I want you to go ahead and look at the graph below and tell me what each of those points represents, what A represents on the graph, B, C, D, and E, and then we'll come back and check each other. Okay, so hopefully you had a chance to kind of quickly go through and look at the graph to determine what kind of extrema are we dealing with. So we can look at A, and A really isn't anything. It's not the highest point, it's not the lowest point, so it doesn't represent any extrema here. B, we can go ahead and call a relative minimum or a local minimum because yes, it's a low point, but it's not the lowest point. C, we can call that a local maximum. D, we can call an absolute minimum or a global minimum. Typically, we'll call it absolute. And then E is our highest point. We can call that an absolute maximum or global maximum. Hopefully you got those right. And if not, you can ask tomorrow. Now we're going to talk about critical numbers. This is something that is going to come up the rest of the time in calculus. So we're going to talk about critical numbers an awful lot. So what is a critical number? A critical number. All right, so let's go ahead and let f be defined at some value c. Okay, so it's defined at this point. So if f prime of c equals 0, or if f is not differentiable, meaning f does not exist at this point. F prime does not exist. Okay, f prime does not exist at this point c. All right, then c is a critical number of f, or critical point. Okay, so we can take a look at the two scenarios. Here's where f prime of c does not exist. Now remember, it is not differentiable if the slope or the derivative on the left does not have the same value as the slope or the derivative on the right. So here we can see we've got a positive slope. Here we have a negative slope. Those don't match. But f prime of c does exist. It's defined. Okay, so this is a does not exist critical number. On this diagram right here, this is an example of f prime of c equaling 0. Okay, so these are our two scenarios. This is when we could potentially have critical numbers. Now we need to talk about relative extrema and where they occur. So one key thing is this theorem 3.2. Relative extrema occur only at critical numbers, meaning if we're looking on a closed interval, relative extrema cannot occur on endpoints, only the critical numbers. Okay, so if f has a relative minimum or a relative maximum at x equals c, then c is a critical number of f. Okay, so it kind of works backwards, right? So if I know I have a relative minimum or a relative maximum at that point x equals c, then I know that c has to be a critical number. Okay, so let's take a look at this first example. And if you're looking at your book and following along, this is the example 2. Okay, so it says, let's find the extrema of this function, f of x equals 3x to the fourth minus 4x cubed, on this closed interval from -1 to 2. Okay, so step number 1, when I'm asked to find extrema, I'm thinking we need to take the derivative. So that's our step 1. We need to differentiate. So if we go through, remember, we take our power, we move it out front, so 3 times 4 is where we get 12, and we subtract 1 from our power, and we do the same thing. Minus, move this power, multiply it by 4, 12x squared, subtracting 1 from that power. Okay, so we differentiated, we've got our f prime. So now, where do critical numbers come from? All right, well, to find the critical numbers, remember, there's two scenarios. It's either when f prime equals 0 and when f prime is undefined or does not exist. Okay, so what we should notice is f prime is defined on this entire interval. So there's no point of x, no value of x for which this function is undefined. So we don't have to worry about that scenario. But we do have to set it equal to 0 to see if we can get any critical numbers that way. All right, so we're setting f prime equal to 0. We go ahead, we factor out that 12x squared, and we're going to get two critical numbers, x equals 0 and x equals 1. So these are the critical numbers, and we got those from setting f prime equal to 0. The last step is to evaluate f at the two endpoints and the critical numbers to determine where the max and min occur. So we test our left endpoint, which is x equals -1. So when we plug -1 into our f function, we're going to get 7. Now we have to test our critical numbers, and sometimes there's 1, sometimes there's none, sometimes there's more than 1, okay, in this case. So when we test x equals 0, we get f of 0 to be 0, okay? Our next critical number is x equals 1. So when we evaluate f of 1, we get -1. And then our right endpoint is x equals 2. So when we evaluate f at 2, we get 16. So now we just go through and we compare these 4 values, okay? And hopefully you can see -1 is the smallest value. So we could go ahead and say that we have a minimum there. And 16 is our maximum. We could say that those are both absolute minimum and absolute maximums here. Now, we wouldn't call 7 a relative minimum because it's on an endpoint, so we can't say that, okay? So this left endpoint, that's nothing, okay? And just a quick note here is critical numbers don't always produce max or mins, okay? So just because you get a critical number doesn't necessarily mean something is happening at that point. Let's get some more practice finding critical numbers. So this second example says find the critical numbers of f of theta equals 2 secant theta plus tangent theta on the closed interval from 0 to 2 pi. All right, so this is a good time to review your trig functions and their derivatives. Okay, so remember I kind of gave you that little cheat sheet in the last video or the last note sheet. So reacclimate yourself with that as well. So I see the phrase critical numbers, or I see that term. First thing I'm thinking is we need to differentiate. So we need to take the derivative of 2 secant theta plus tangent theta. All right, so if you remember, the derivative of secant theta is secant tangent. So we have 2 secant tangent, and what's the derivative of tangent theta? Secant squared. So here is our f prime. Okay, so now how do we find critical numbers? Well, in order to find critical numbers, remember there's 2 scenarios. When f prime equals 0, or when f prime is undefined or does not exist. Okay, so I'm going to first set our f prime equal to 0. Notice we can factor out a secant theta, so when we do so, we get 2 factors. Setting each of those factors equal to 0. Let's go ahead and focus on this left side first. Secant of theta equals 0. Well, what's another way to rewrite secant is 1 over cosine theta. Aha, this is where we're going to be undefined because we can't have our denominator equaling 0. So it's really undefined when the cosine of theta equals 0. Okay, so now we need to go back to our unit circle. All right, so reacquaint yourself with that unit circle. When is cosine of theta equal to 0? Well, hopefully you remembered. Cosine of theta is equal to 0 when theta equals pi over 2 or 3 pi over 2. So we're going to kind of think about those for a little bit. We're going to hold on to those, and we have some critical numbers there. Okay, but there's still another scenario, right? We need to figure out what values of theta makes this factor 0. So we go through, and we have 2 tangent theta plus secant theta equals 0. And just quickly rewriting, tangent is sine over cosine, secant is 1 over cosine. Multiplying everything through by cosine, we're left with this equation here. 2 sine theta plus 1 equals 0. So we subtract 1 and divide by 2. So we have sine of theta equals negative 1/2. So kind of picture this on our unit circle. Right, we have our unit circle. All right, when does sine, and remember we've got all students take calculus as a good reminder, okay? And when does the sine of theta equal negative 1/2? Well, that's, kind of down here when we have this ordered pair of what, negative root 3 over 2, comma, negative 1/2. Sorry, that's hard to read. So when is that? Well, hopefully you remember that is when theta equals 7 pi over 6, okay? And then when does theta equal negative 1/2 again? Oops. When we're over here and we are at the point root 3 over 2, comma, negative 1/2. So where does that put us? Hopefully you remember that's when theta is 11 pi over 6. So there are other 2 critical numbers, and those came from when we set f prime equal to 0. So overall we have 4 critical numbers, and we list them all in order. If I wanted to find any extrema, both relative or absolute, that's where you would use your table, plug in the endpoints, plug in the 4 critical numbers, test all 6 values, and then take a look from there. This last example is more of a calculator example, so we will get more practice with the calculator together in class, but I'm going to quickly walk through this problem, so if you'd like to practice it on your own, you're more than welcome to. So a woman pulls a sled which, together with its load, has mass m kilograms. If her arm makes an angle of theta with her body, assumed vertical, and the coefficient of friction, a positive constant, is mu, the least force F she must exert to move the sled is given by that formula. If mu is 0.15, find the maximum and minimum values of F for that certain interval. Give answers as multiples of milligrams. Okay, so one key here is I see find the maximum and minimum. So that should trigger something. We need to find the derivative, right? Now, if we were to plug 0.15 in for mu and kind of forget about this milligrams, right? That's just our unit. We could go ahead and find the derivative. Now, I did that really quickly, okay, and just showed it here. If you have questions of how that got to be that way, we can certainly go through it. All right, so what would we do on our calculator for a problem like this? Because this isn't so nice to actually go through and plug on our calculator multiple times. So how can we help ourselves out? Well, if I'm using my calculator, I would plug the function into y1. And then in y2, we would use that n-derived function. So again, I posted here, this is what it would look like if you had the old version of the TI-83. If you have the TI-84 or a newer version of TI-83, you would get like this new math look. So it would look like this, but you would type in accordingly. Okay. Now, when you're ready to graph, the only thing you need to graph is your derivative. So make sure only y2 is highlighted. Okay. So you can use your graph to find when f prime equals 0, because remember, our maximum and minimum values, we need to find our critical numbers, and those occur when f prime equals 0 or when f prime doesn't exist. So from our calculator, we can get this value of theta, okay, by calculating the 0, all right? Now, how do we determine when f prime doesn't exist? Well, that's why I gave a little side note here of what f prime is. So f prime wouldn't exist when this denominator equals 0. So that's what I showed right here. Okay, so now if we quickly go through and we solve this, I'm going to zoom in a little bit. We could go ahead and, all right, so we subtract 0.15 cosine theta, divide by cosine. Remember, sine over cosine is tangent. And then we can take the inverse tangent of that value, and we get our theta value. Okay, so now we've got two critical numbers. But one thing we have to take a look at and remember is our interval goes from 0 to pi over 2. So this critical number is outside of the domain, so we don't even worry about that. I just kind of toss that to the side. So now when I'm trying to find my max and min values, if we have them, we test our endpoints and any critical numbers. So again, I'm not going to worry about this critical number that's outside of our domain. I'm only going to focus on that first critical number when I'm testing. So we can set up our table of values. We have our endpoint when x equals 0, and we have our other endpoint that should say pi over 2, not 2 pi, f of pi over 2. And what do we get? We should get these values. You could use your calculator. And we would find that our maximum occurs at when x equals 0. We get a maximum of 1. And our minimum occurs at f of 1.4219, et cetera, et cetera. And a minimum is 0.1483, et cetera, et cetera, et cetera. Okay? All right, so like I said, I quickly went through that. We will get more practice using our calculator and making sure we're comfortable with that. In the meantime, have a good night. See you later.